So we're looking at another fundamental counting principle. We'll read through our question and we'll talk about essentially what this is. Or actually, I didn't put enough information, so we'll talk about it first. We're talking about euchre hands, and euchre hands are special types of decks that only use aces, face cards, tens, and nines. Our very first question, so our first example is going to ask us how many different hands are possible. So in a euchre deck, there's 5 cards. Okay, so essentially we're going to use 5 placeholders here. We have your first card, we'll call it, I guess, card 1, card 2, card 3, card 4, and card 5. Okay, and when they're asking how many cards are possible, well, what we need to find out here is how many cards are there. Well, we've discovered that there are 4, 12, 4, and 4. Okay, so that means there are a total of 24 cards. So if we're using placeholders to do this, instead of building it as a combination, what we can say is if I'm just drawing randomly from a deck, my very first card, I have 24 opportunities, kind of like probability. There are 24 choices from there. The next card, well, because I've already drawn one, there are now only 23 cards. And then that kind of continues down that pattern all the way down to our 5th card, there are 20. So when you go through this, and you multiply them all, this will tell you when you multiply them how many possible hands there are. And that's very similar to your 24 choose 5, is it, you said? When we set that up, we'll show you how they kind of look the same here. N minus R, our N value and our R value. So when you set that up, N factorial would be 24 factorial. So essentially 24 by 23. I'm going to go all the way down to 20 here. 22, 21, 20, and then dot, 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 all the way down to 1. Okay? It's then divided by, and I'll do a little side calculation. N minus R in this case is 24 minus 5. Okay? Which gives us 19. I don't know why that was so hard for me. Okay, 19. So we have 19 factorial on the bottom. So when I write out 19 factorial, it's 19 by 18 by 17, all the way down to 1. Now, because this is division, and there's multiplication on the numerator and denominator, but because they're divided by each other, essentially from here we go 19 down to 1. Because there's 19 all the way down to 1 on the top and the bottom, these two essentially cancel out. They create a 1, as we would call it, and you're left with just 24 by 23, by 22, 21, 20, all the way down to 20, which is essentially what we found with our placeholders. So either doing this with placeholders or combinations, you both get to the same answer. Whichever you find easier, I would suggest to use. Okay, so that's kind of the very first example. Second example says how many possible hands are there with at least 1 card from every suit. So this is where the placeholders come in handy because they really help us organize stuff. Let's do this one in a different color. Okay. Again, we have 5 placeholders. So card 1, card 2, card 3, card 4, and card 5. Okay. And we said we wanted one from at least every suit. So we got to figure out how many cards there are from every suit. We know there are 24 cards, and we assume it's a normal deck of cards, so there are 4 different suits. So essentially, we're splitting these into groups of 4. So when we divide this by 4, we should end up with 6 cards in every suit. Okay. So this is where it's similar to fundamental counting principle. So let's say we need one that is going to be a heart. Well, we have 6 hearts to choose from. Okay. Then we want one that's going to be a diamond. Well, then we have 6 diamonds to choose from. Then we want one that's going to be a club. Ooh, I should be an artist. That's all right. There's 6 clubs, and then we have a spade, which is there are 6 to choose from. Now, this is where the 5th card becomes very interesting. You have to remember that we've now chosen one from every one of these decks. Okay, so essentially there are 4 cards that have already been drawn. So when we go to draw the 5th card, okay, we have the total of 24 minus the 4 cards that we've already drawn. So our 24 subtract 4 gives us there's a total of 20 cards left in the deck to draw from. So we then multiply by our 20 to figure out what our fifth one. And our fifth one, I'll give it a star. It could be any suit. It doesn't really matter. But we've now met our requirement for all the others. So when we go about multiplying this is 6 to the power of 4 times 20. So a 6 by 6 by 6 by 6 by 20. 25,920 is the number of solutions, or the possible solutions we can get, which is much smaller. Even though we didn't calculate this one, it's a lot fewer hands to actually choose from.